In this video, we are going to discuss the topic refraction of light through a prism. So let us first of all start with the definition of the prism itself. A prism is a transparent medium bounded by 5 plane surfaces with a triangular cross-section. So a prism is a refractive medium which is bounded by 5 plane surfaces, out of which 3 will be rectangular and 2 will be triangular. And thereby the cross-section of the prism is also triangular. So this is what a prism looks like. It's a 3D picture, and you can see that a prism is bounded by 5 faces or 5 surfaces, out of which 3 are rectangular surfaces and 2 are triangular. The 3 rectangular faces are respectively A, C, F, D, A, B, E, D, and B, E, F, C. B, E, F, C in itself is the base of the prism. Also, the 2 triangular faces are A, B, C, and D, E, F. Now, the 2 rectangular surfaces A, C, F, D and A, B, E, D, which are marked by blue color in the picture, are also called the refracting surfaces of the prism. Now they are called refracting surfaces because it is through these 2 surfaces that refraction takes place in a prism. Furthermore, the angle between these 2 refracting surfaces, denoted by the angle A over here, this angle A is also called the angle of the prism. So the angle between the 2 refracting surfaces of the prism is also called the angle of the prism. In this picture, we are only looking at the principal section of the prism, which is A, B, C. Here, AB is one of the refracting surfaces. Let me say the first refracting surface, and AC is the second refracting surface. And we have ray of light coming from this side. So PQ is the incident ray. So we have a ray of light PQ being incident from a rarer medium, and it is entering a denser medium. So we know that whenever a ray of light comes from a rarer medium to a denser medium, it bends towards the normal. And the normal to the first surface is DQE. So we very clearly see that the refracted ray is bending towards the normal DQE. Now for refraction taking place through the second refracting surface AC, QR is the incident ray. And this incident ray QR is coming from the denser medium and going towards a rarer medium. So we know whenever a ray of light comes from a denser medium to a rarer medium, it bends away from the normal. And the normal to the second surface is YRZ. So RS, we can say, is the emergent ray. So remember, angle I is the angle of incidence. Angle R1 is the angle of refraction on the first surface. Angle R2 is the angle of incidence for the second surface. And angle E is the angle of refraction on the second surface, or rather, this is the angle of emergence. Now, if this prism ABC was not here, then the incident ray PQ would have continued to travel in this direction, that is along PQML. But because of the prism, refraction is happening, and thereby what happens is, the ray of light which was initially traveling in this direction along PQ or PQML eventually comes out along MRS. So it comes out in this direction because of the refraction taking place through the prism. So what happens is, there is a deviation in the direction of movement of the ray of light. The ray of light was traveling in this direction, but because of refraction happening through the prism, the ray of light emerges in this direction. So since there is a deviation in the direction of movement of light, this angle over here, this angle LMR or LMS, is called the angle of deviation, and it is denoted by a Greek letter delta. So this delta denotes the angle of deviation of the ray of light. Now, there are a couple of relations that you need to remember with regard to refraction taking place through a prism. Now, if you want to see how we land up at these expressions or these relations, the derivation is given in the book. It's not a very lengthy derivation also, but it's not there in the syllabus. What you only need to remember, taking into consideration the syllabus, are these relations. So let us give a look at the relations. So the first one says angle R1 plus angle R2 is equal to angle A. That is, this angle of refraction on the first surface and angle R2, which is the angle of incidence on the second surface, the sum of these two angles is equal to the angle of the prism. The angle of the prism meaning this angle over here, this angle, angle A. So this is one thing. I have shown these two relations to be two different things, but it's one and the same actually. Okay, so first let us give a look at expression 2. Relation 2. The angle of deviation is equal to angle of incidence plus angle of emergence minus angle R1 plus angle R2. But since this we've already seen is equal to the angle of the prism, so therefore angle of deviation is equal to angle I plus angle of emergence minus the angle of the prism, which can also be rewritten as relation 3. Angle of incidence plus angle of emergence is equal to angle of the prism plus angle of deviation. Now these are some of the relations that you need to remember.